We are here to be able to discuss how we got the answers to the group problems and to show a little bit of our work and how we did that.
All right. So for question number 1, it talks about the different blood types everybody can have, and then here this is what they give us for the child, the mom, and the dad. Oh, yeah, and then
Yeah.
oh yeah, okay, and then and then it asks you to solve for the genotypes for the parents and the child if given these, or to figure out which genotypes are from these phenotypes. Which we did by doing different Punnett squares. And then we got the child is little I, little I, little r, little r, big M, and the mom was little I, little r, big M, big N, and then dad was big little I, big R, little r, and then big M, big M.
So the easiest way that we did this is we just took what we knew, and we just made a Punnett square out of that. And so, for example, it had to be II, because the only way that you can get blood is to have II. And using that information, we just made different Punnett squares to be able to figure out what each one had. Question B was asking about it's kind of around the same thing about blood types. It's asking, there we go, about it gives the genotypes of the parents, and it asks like what the ratio of the genotype of a child with type B blood, Rh negative, and MN would have. So we took that, we used the 4-line method with the parents' information, and we ended up getting 1 out of 32 of their children would have this kind of blood.
Yep, and then for part C, same kind of thing, except for they're asking for A, Rh plus, and then M. And then, so for that answer, we ended up getting 3 out of 64. Their children would have that.
Cool. Question 4. There's a man with, and then it gives his genotype or his phenotype, and it says that he doesn't believe that he could be the father of a child with O blood, Rh negative, and MN. And so to decide if we could prove him wrong or not, we took the genotypes that we had and we tried to make Punnett squares to be able to see if that's correct. That if the father has these phenotypes that she's writing on the board, and the mom has the phenotypes that she's going to write as well, could have O, Rh negative, and MN. And so the genotypes would be the child would have let's see here. Sorry, the father would have B, I, R, M, N, and then the mother would have A, I, R, R, N, N. And so if that were to be the case, then the child would have this as their genotype.
Okay, and then for question number 2, talk about the walnut, rose, pea, and single cones. And for the walnut, we have this, rose. So, based on these, we were able to produce different Punnett squares in order to get the ratio that we wanted. So, for example, for the first one, we knew that for a walnut, it has to have, well, I guess, for single, I'm backwards. For single, we know we have to have at least a recessive and a recessive. So we knew so for these will make the recessives, those will make the recessives, and then we need recessive for the P ones also, and then for the rose and the walnut, we needed just a dominant R for both, and then for the walnut we needed a dominant P also, so that's how we got R, R, P, P, R, R, P, P. And yeah, that process is pretty much the same for the rest of question 2 with just the different ratios.
Cool. Yeah, so the rest of question 2, like you said, we just did that. Use the same kind of methods to be able to figure out what the rest of the genotypes of the parents would be. Question 3 was talking about horses. There's 3 different kinds of horses: Palomino, chestnut, and Cremello. And so it's asking what kind of inheritance trait these horses would have. There's 3 main ones that we went through: complete dominance, incomplete dominance, and codominance. And based off of the kinds of offspring that they had, we knew that it couldn't be codominance, and we knew that it couldn't be complete dominance. If it were complete dominance, the ratios of the offspring would be different, and if it were to be codominance, then the ratio would have been different as well. And so incomplete dominance was the one that we found fit the ratios of the offspring that they had. On top of that, we also took the horses that were created the most and the ones that were created the least, and we used that to help us to determine which ones have the dominant and which ones have the recessive allele. And so we found that Palomino was heterozygous, chestnut was homozygous dominant, and Cremello was homozygous recessive.
All right. And then for question 4, most of the terms we just looked up in the notes, whether it be in PowerPoint, the ones that we took, or the lecture notes from the professor. But I'll go over part G and H, and they both go over the maternal effect. So for the stable one, we got 80% of the offspring would have dextral, because in the genotype for the mother, we had DV as 30%, and then capital D, lowercase d as 30%, which would make this. And then for sinistral, it was 30%, 40%, sorry. And that was just because in the original, in the mother's genotype, we had lowercase d was 40% also. So that would stay the same. And then for part H, with the leaf pigmentations, since the female was 40% green, thank you, green, and then 60% white, that would not change onto the offspring since it is the maternal effect, so this will just stay the same.
So then we get to the last question, question 5. Question 5 asks about 4 different alleles, and they're found in different kinds of horses. So the phenotypes of 4 different horses are black, sepia, cream, and white. Each one showing dominance over the other. So on top is black, which is more than sepia, which is more than cream, which is more than white, white being the most recessive allele. And so each part, A, B, C, and D, gave us different ratios of phenotypes found in horses, and asks what the offspring of them, gives you the offspring, the phenotypic offspring of the different horses, and then asks you what the parentage would be. So, for example, the first question says 50% are black, and 50% are going to be sepia. After you kind of get this down, you mostly just do it in your head. But you can take like a Punnett square, and you know that one of them can't be totally black. Because if it were black, then everything would be dominant. So there has to be a black allele, but there also has to be a sepia allele in one of the parents. And then the other one, to get half, has to be sepia. And so that would make half of them black and half of them sepia. And the same thing can be done for the other questions, B through D. Just use the information that's given to you and use that and your common knowledge about genetics to be able to figure out the problems.
All right. Thanks for watching, guys.